Hello viewers, welcome back to my class. We are still on 2026 WAEC chemistry practical on salt analysis. Although I've released the first video on this aspect, but I have to restructure my questions. So if the questions come in this way, how can you answer it? I'm still going to start from the beginning for viewers who are coming across my video for the first time. So like I said, that our sample for this year will be label C. You will be provided with a sample label C. Then what is sample C? Sample C is a mixture of lead carbonate and starch. Sample C is a mixture of lead carbonate and starch. So we are going to look at the state of the two samples. We are going to talk about their solubility. Then we look at the possible chemical test on the two samples. So let's talk about the solubility of the two samples. Lead carbonate is insoluble in water. Lead carbonate is insoluble in water. That is, lead carbonate cannot dissolve in water. Likewise, starch. Starch is insoluble in water. It shows that the two samples are what? Are insoluble in water. Now let's look at what are the chemical tests that we should be expecting on the two samples. Let's consider lead carbonate first. So we should be expecting chemical tests on lead ion. Then we should be expecting chemical tests on carbonate. Then starch. Now we are going to look at the reagents that we can use to confirm the presence of lead ion in an unknown sample. What are the reagents that we can use to confirm the presence of lead ion in an unknown sample? So lead ion is a cation. Then we always use sodium hydroxide. Sodium hydroxide to confirm the presence of cations. Then we can also use aqueous ammonia. Then for lead, we can use dilute hydrochloric acid. Then plus heat. Then we can also use potassium iodide. But potassium iodide is not part of the reagents listed in our practical instruction. Now let's look at carbonate. How can we confirm the presence of carbonate in an unknown sample? Then we can use an acid. We can use dilute acid to confirm the presence of carbonate. When an acid comes in contact with carbonate, there will be effervescence of colorless and odorless gas. So that gas is what? Is carbon 4 oxide. So there will be effervescence of carbon 4 oxide, which is colorless and odorless. Then we confirm the presence of carbon 4 oxide by passing the gas through lime water. So it will turn lime water milky. Then we can also use what? We can use barium chloride, aqueous barium chloride, then followed by addition of hydrochloric acid or HNO3, dilute hydrochloric acid or HNO3. Now, not only carbonate 4 compound that we can use barium chloride to confirm. Then we can also use what? Barium chloride to confirm the presence of SO4 2-, SO3 2-. So the following anions will give white precipitate on addition of barium chloride. They will give you white precipitate when aqueous barium chloride is added. Now to confirm the presence of carbonate, you add hydrochloric acid. So when hydrochloric acid or dilute acid is added, there will be effervescence of colorless and odorless gas. That is, carbon 4 oxide will be evolved. Now let's look at starch. Let's look at starch. You confirm the presence of starch in an unknown sample by adding iodine solution. So addition of iodine solution to an unknown sample contains starch will turn blue-black. Blue-black coloration will be formed. So let's answer the following questions on the board. So you divide your book into 3 columns. the first column is for test. Then the second one is for observation. So while the last one is for inference. So let's start. The question says that C is a mixture of two samples. Carry out the following exercises on C. Record the observation and identify any gas or gases involved. So the first question says that to sample C, add 10 centimeter cube of dilute HNO3. So sample C plus 10 centimeter cube of dilute HNO3. Don't forget that HNO3 is an acid. Then when an acid comes in contact with any thiazocarbonate 4 compound, when an acid comes in contact with any thiazocarbonate 4 compound, there will be effervescence of colorless and odorless gas. Now let's look at chemical reaction between this thiazocarbonate 4 and HNO3. Let's look at the chemical reaction between this thiazocarbonate 4 and HNO3. So when thiazonitrate 5, when thiazonitrate 5 reacts with carbonate compound, it will give you lead nitrate. So what we are going to get is a clear solution of what? Of lead nitrate. Because this lead carbonate will dissolve in what? Will dissolve in nitrate. It will dissolve in nitric acid to give you a clear solution of lead nitrate, then followed by water with effervescence of colorless and odorless gas. So this colorless and odorless gas will escape. This one will escape in form of gas. Now, we should not forget that our sample C is a mixture of this lead carbonate and what? And starch. It is not only lead carbonate that we have in C. We have starch and lead carbonate. It is only this lead carbonate that will dissolve in HNO3. Starch will remain insoluble in HNO3. So what will be our observation? What will be our observation? Don't forget that only lead carbonate will dissolve in nitric acid. Only lead carbonate will dissolve in nitric acid. So starch will remain insoluble in nitric acid. So we are going to say C partially dissolved. C partially dissolved. That is, the starch remain insoluble, but lead carbonate dissolve. C partially dissolved. Then what is going to happen? There will be effervescence of colorless and odorless gas. There will be effervescence of colorless and odorless gas. So effervescence occurs. Effervescence occurs. Then colorless and odorless gas evolved. Colorless and odorless gas evolved. Now to confirm the presence of carbon 4 oxide, so the gas will be tested with lime water. So the gas turns lime water milky. The gas turns lime water milky, and what? Blue litmus paper to red, because carbon 4 oxide is an acidic gas. Turns lime water milky and blue litmus paper to red. So what will be our inference? What will be our inference? So you cannot confirm the presence of any cation or anion. You cannot confirm the presence of any cation or anion. Since we have effervescence of colorless and odorless gas, so what we are going to write here is that the gas the gas is CO2. CO2 from CO3 minus or HCO3 minus. Then don't forget that for the last statement says that the gas turn lime water milky and blue litmus paper to red. Then it is only an acidic gas that will turn blue litmus paper to red. So for the last statement, we are going to say that the gas is acidic. The gas is acidic to litmus. The gas is acidic to litmus. So that is question A. So let's move to question B. Let's move to question B. So question B says that, now part of question A says that add 10 centimeter cube of dilute acid. We have not completed question A. Filter, keep the residue and divide the filtrate into 3 portions. Filter. Now the next thing we are going to write is what? Filter. So after filtration, what will happen? Don't forget that the starch remain insoluble. So it shows that what we are going to have as residue will be what? Will be starch. The starch will remain as residue on the filter paper. Then don't forget that lead carbonate dissolve in nitric acid. Lead carbonate dissolve in dilute HNO3. So our filtrates will be what? Will be lead nitrate. Our filtrates will be lead nitrate, because when lead carbonate reacts with dilute HNO3, so we have what? A colorless or clear solution of what? Of lead nitrate, then effervescence of colorless and odorless gas. It shows that that solution is what? Is lead nitrate. So we are going to be left with what? With lead nitrate. So our filtrates now will be what? Will be lead nitrate. Then the starch will remain insoluble. So what we are going to filter out as our residue will be what? Will be starch. Will be part of the starch. Now what will be our observation after filtration? What will be our observation? So we are going to say that colorless filtrate and white residue was obtained. Colorless filtrate or white residue was obtained, or slightly cloudy filtrate and white residue was obtained. Now, which is still part of our what? Our question A. This is part of our question A. So let's move to question B. So B, Roman figure 1. So the question says that to the first portion of the filtrate, so we are going to say that to the first portion of the filtrate. So we add what? We add aqueous sodium hydroxide. We add aqueous sodium hydroxide in drops. First add in drops and record your observation. Plus aqueous sodium hydroxide in drops. So what will be our observation in drops? Then we should not forget that we are using this aqueous sodium hydroxide to confirm the presence of cation. Then the only cation there is what? Is lead. The only cation there is lead. Now, what is going to happen when aqueous sodium hydroxide is added to the filtrate? Don't forget that the filtrate contain what? Lead nitrate. The filtrate, our filtrate is what? Is lead nitrate. Now, so what is going to happen on addition of aqueous sodium hydroxide to the filtrate? So we are going to have white precipitate. White precipitate is formed. So white precipitate is formed. Now for this question B, for the first step, on addition of what? Of sodium hydroxide in drops. So what will be our observation? Then what are the two cations that will give us white precipitate? Those two cations are lead. Lead or calcium. Lead or calcium will give us white precipitate, while aluminium or zinc will give us white gelatinous precipitate. So we are going to say lead ion or calcium ion is present. Now you add what? You add aqueous sodium hydroxide in excess. Then another line in excess. So what is going to happen in excess? The precipitate dissolved in excess. The precipitate will dissolve in excess. Now you write the precipitate. PPT is precipitate. The precipitate dissolves in excess. So the precipitate dissolve in excess to confirm the presence of lead ion. So lead ion present. So we have answered B Roman figure 1. Then let's answer question B Roman figure 2. Let's move to question B Roman figure 2. B Roman figure 2. B Roman figure 2 says to the second portion of the filtrate, add ammonia, aqueous ammonia in drops, then in excess. Now we are going to say that filtrate, the second portion of the filtrate plus aqueous ammonia in drops plus aqueous ammonia in drops. So on addition of ammonia to our lead nitrate, don't forget that our filtrate is what? Is lead nitrate. So on addition of aqueous ammonia to lead nitrate, what we are going to have is what? White precipitate. White precipitate is formed. White precipitate is formed. So inference will be what? Pb2 plus is present. Then in drops and what? And in excess. You add in drops, then you add in excess. So what is going to happen in excess? In excess. So the precipitates will remain insoluble in excess. The precipitate will remain insoluble in excess. So the precipitate remains insoluble in excess. So which confirm the presence of lead ion. Lead ion is present. So let's move to question B Roman figure 3. Question B Roman figure 3. So B Roman figure 3. So to the third portion, add dilute hydrochloric acid. To the third portion of the filtrate. So filtrate plus dilute hydrochloric acid. Filtrate plus dilute hydrochloric acid will give us white precipitate. white precipitate is formed. White precipitate is formed. Then what will be our inference? That will be Pb2 plus is present. Then the question says that it's the mixture after addition of dilute hydrochloric acid. It's the mixture, then plus it. So what is going to happen on heating? So the precipitate dissolved or disappear. The precipitate dissolved or disappears on heating. The precipitate dissolved or disappears on heating. Then what is going to happen after cooling? So the question says that then allow to cool. So another line, plus cool. So the precipitate will reappear on cooling. The precipitate reappears on cooling. So which confirm the presence of lead ion? The precipitate will reappear on cooling, which confirm the presence of lead ion. So we are going to write lead ion is confirmed. Lead ion is confirmed. Now let's move to question C. Let's move to question C. Then question C says that to the residue from A above, add iodine solution in drops. To the residue in A above. Don't forget that the starch remain insoluble in what? In nitric acid. The starch remain insoluble in nitric acid. So our residue contains what? It contains starch. So we are going to say that residue. So that is our question C. Residue plus iodine solution. So residue plus iodine solution will give us what? Blue-black coloration. Blue-black coloration is formed. So blue-black coloration confirms the what? The presence of starch. So therefore starch is present. Starch is present. So we have answered all the questions. It's as simple as that. Please don't forget to like, share,